All right, absolute value function, part two. We're just learned about the basic graph. There it is. You just saw that. And now we're going to do some transformations to it to see if we can know the basic shape. So maybe we'll practice the basic shape so that what we'd call the parent function is just the regular absolute value function. And how we would actually graph that is we know it's this V shape that goes perfectly up at a 45-degree angle, over one, up one, over one, up one, and we can draw that really quickly, probably faster even than a parabola, right? It's so straightforward, that V shape. So this is the regular unstretched or whatever graph. Um, and I'm going to put some arrows on there so it looks great. Great, great, great. And that's the basic graph. Um, Probably a good idea to include that, I'd say. So this next one then, what's happened to it? I'm going to maybe make it blue just so I can tell the difference between the two graphs. Well, the -3, that's the difference, isn't it? That's -3. What does it do? Well, since it's in with the x, in with the x means it's going to do something in the direction of x, right? So it's a horizontal something. Is it a stretch? Is it a squish? Is it a move left or right? Well, all of these things, the transformations, we will review and soon, probably by the end of the week. But hopefully you remember that in the direction of x, it's opposite that you'd think. So you think -3 should be a move left, but it's not. It's a move to the right 3. And that's it. So this graph has been moved right 3, each of the points, and I could move each of the points right 3, each of my nice points right 3 if I like, or I could have just moved my starting spot and drawn the same shape graph, right? Because there's no stretches or anything like that. Blue. Beautiful. And that's that one. And of course, they get a little more challenging. I'm gonna make this one purple. Why not? Just because I can. So what are the two things doing? Notice that the 2 and the 1, -1, aren't in with the x, so these are going to be vertical somethings, right? Um, the -1 is a move down. In the direction of y, it's exactly what you'd think. In the direction of x, it's opposite. In the direction of y, it's exactly what you think. This would move down 2, and or down 1 rather. And this 2 is multiplied, and it's exact multiply. You think it should make it bigger or steeper or whatever, and it does. So this is what we would call a vertical stretch, fancy math word, expansion, right? Stretch, expansion by a factor of 2. So that means here all of the y distances, all the distances are doubled. So if I start with my original black one, all these distances are doubled. So where it was 1 unit, now it's going to be 2 units, right? Where it was 2 units, now it's going to be 4. Where it was 3, it's going to be 6, and I end up with a graph that's steeper. Where it was 1, now it's 2. Where it was 2, now it's 4. Where it was 3, now it's 6. It's doubled. And in fact, you can kind of see the steepness of the line has increased, hasn't it? And that's exactly what's gone on here. Okay, well, Mr. Estall, you forgot about the move down. Well, I'm doing it in 2 steps. We're just getting used to these absolute value graphs, so I'm kind of taking my time and trying to do a good job. This is our first stab at transformations as well. It is review, I realize that. However, um, it's our first time at it. So, and we'll get lots and lots of chances. So this purple graph, what's its equation? It's not the final graph yet. It's just the normal graph that's been vertically stretched by factor 2. Now this purple graph, all I have to do is move it down, right? That's the goal now, is just to move this purple graph down by 1 unit. And this is starting to get a little bit jumbled, but we'll be okay. And again, I could move each of my points down 1 and transform it that way, or know that my starting spot moves down and then I have exactly the same shape. So this steepness is doubled from there. Well, how did you know to do the steepness first? Well, if you remember from grade 11, that was kind of a rule that we said. We said usually we do the stretches or squishes, expansions and compressions, and reflections first before we do our moves left and right or up and down. So generally, oops, that's what we do. And I'm going to have to just write this in kind of like that. That looks okay. So in general, do expansions or compressions, the stretches and squishes, or reflections, right? What do I mean by reflection? Remember, if this was a minus, then the V shape would open down, be flipped over the x-axis in the direction of y, and be flipped down. So do these things first, then up, down, left, right, left, right. But this is usually, and we'll actually talk about this in quite some detail. Where's the homework? Hopefully you got the home. Oh yes, in class we do have an activity that we'll complete with a partner. This is actually a practical application of absolute value function. I think it's from biology, I believe. Often we use it in physics, but I think this is a biology example. And then we'll get into the homework. And then you finish the class off with the FAQs. So thanks for coming out, folks. That's it.